So today we will be discussing about the next examination, which is IIT JAM Mathematics 2022. So for this, we need a strong background of real analysis. So I am making this series from now onwards, and I will continue it till next year, till your exam. So we will start from the starting. So no worries. So because the real analysis part is most important part in any exam, so I will be starting with the concept of the sequences. And you see, the syllabus consists of the sequences, convergence, and so many things about the real sequences. So let's start with the sequences. So we will cover these topics. So basically the idea is that we will cover this one, we will cover this one, and we will cover this one first, then we proceed as soon as it will be over. So let's start. Okay, so what do you mean by sequences and why they are useful? Okay, so sequences are useful to approximate the quantities. So suppose if I have this 1 by 3, then what does it mean? It means that you can write it as 0.33 or 0.333, right, and so on. So what you get is that 0.3, 0.33, 0.333, and so on. Like, so these things are approximating to 1 by 3 more closely, right? So this is more closest approximation, this is less. So the idea behind the sequence lies in these things. Okay, so what I say is that the notion behind this that is, what if this is 1 by 3, then can you find x such that its difference is less than 1 by 10 to the power 3, something like this? Can you find? The idea is using sequences, right? So we will see it later, but yeah, the idea is that you can see that 1 by 3 is written like this, although 1.4, where does it goes? 1.414. So you see that it converges to, it is going towards root 2. I'm not using the word converges because you are not familiar with this. So 1.4, 1.41, 1.414 is going towards root 2. But this is the, at last point, this is the approximation of root 2, right? So we are getting close to root 2. So idea behind sequence is approximation. This is the idea. I just write it more clearly. This is approximation, right? So the idea behind sequences is approximation. So how you can replace means up to a level of accuracy, you can write xn as x, I mean to say xn, the value of like 1 by 3. If you take x is equal to 1 by 3, then what you see, you can write, if I say that I want 10 to the power minus 3 difference between the term and 1 by 3. So you can take this 333, so whatever you like. So this minus 1 by 3 mode is 10 to the power minus 3. So idea behind this is same as approximating. So if a term is bigger than this, then you can take this in this thing, okay, then it is less than this. Okay, so that's the idea. Okay, this is minus. So इस पे इतना focus नहीं करना है. We don't need to focus on these things, but I want to give just an idea of sequences. So let's start with sequences main definition. Okay. Okay. So sequence, I just cite sequences and convergence, right? I just use the word convergence. Okay. So what is the definition? So firstly, I use another pen. Firstly, use this let, if you have a set X be a non-empty set, so what be not empty, right? Right, X be non-empty. So what do you mean by a sequence? So a sequence in X, what does it, a sequence in X is a function, right? It is a function f from n to x. What is n? N here is natural number. This is a natural number set. So, and this is a function from set of natural numbers to x, and we let, what we let, xn is equal to f of n, right? So what is the idea is that the members, one map to some member of x, two map to some member of x, that is a function maps every member of natural number to some element of x, that we write xn is equal to fn. We let this thing, okay, and call xn the, and okay, and xn is nth, you say it is just the nth term of the sequence. Okay, that's it. Okay, so that's the idea of it. Okay, I just use it. So this is the nth term of the sequence, right? This is the idea. So the idea is, I think it is more clear. So I think it's fine. So you can replace this function f by xn. So replacing, yeah, I can zoom it, replace f by xn, or what is the range set? Means the function values, what are x1, this is x1, x2, this is x3, this is going to x4, this is moving, okay, that's it. So this is the whole thing, and this is the sequence definition. Okay, so now we visualize this graphically. Okay, we will try to visualize the sequence graphically. This is the common notion, right? We assume it, we make it graphically. Okay, so I again zoom it. So graphically, how to say this, let's see. So graphically, let's see, suppose xn is a sequence in R. Xn is a sequence in R. So what is sequence? I just mentioned earlier, sequence in R. Xn is a sequence in R means function from n to R, and that function f is xn, n to R, and taking values in real line. So what I need to do is plot this function, right? Xn is a function, so I need to plot this sequence. Sequence is a function, right? So how you plot this? Can you plot this? Let's see. So it is nothing but function from n to R, and you know how to plot functions, right? It is function from n to R. So how to plot this? I just take a point from, if I take k belongs to n, and xk is the mapping, means it is just the fk which belongs to real line, then I can plot this well, right? So how you plot, let's see. If you have 1 here, I just zoom it, 2, I just map first, 4, 5, and so on, right? You have points. Okay, and there are members of, like, okay, this is fine, right? So f1 is something here. You can represent 1 comma x1, right? Okay, you can map 1 comma 2 comma x2. Like this, you can map 3 comma x3 and so on, right? So this is the whole thing. So that is the representation of sequence in R. Okay. So that's it, and that is the idea. Now अब हमें कुछ एग्जांपल्स देखने होंगे सीक्वेंसेस के. तो कैसे हम सीक्वेंसेस के एग्जांपल्स देख सकते हैं? Some examples, right? I just use another pen. Okay, some examples. So which examples we are going to see? First one is, you can take a function which is constant, right? This function, and C is in R. C belongs to R. Okay, so you can take this function. Okay, fine. Then how you plot this sequence? It is just the constant sequence. You can write this C, 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 and so on, right? Another thing is, if you consider this sequence 1 by n, then what does it says? It is the sequence like 1 map to 1, 2 map to 1 by 2, 3 map to 1 by 3, 4 map to 1 by 4, and this thing, right? Next is, third one is, you can see, is xn is equal to minus 1 to the power n. So these are very important sequences, I see. So how it is look like? Minus 1, 1, minus 1, 1, and so on. Like you can write this. Fourth important example is n. These are the function, like you write f of n is equal to n. This is just xn, and xn is just n, right? So it is just a function. I'm not writing it as like this xn. Okay. So what is the value? 1 map to 1, 2 map to 2, 3 map to 3, and so on. Okay, fine. So that's the idea. And similarly, you have many sequences like these. Okay. So basically, there is another sequence that I have mentioned earlier. X1 is equal to 0.3, right? X2 is equal to 0.33. What is, where does it goes? You know that goes to 1 by 3 that we have seen. Okay, but we will understand what it does it mean by goes to or not. Okay, so that's the idea of it. Now we are going to discuss the convergence definition. I think it's very well clear what I have shown here, these things. So I just say, so let's again see this definition. Please understand this one. You know x be known empty set. Sequence is a function, that's this, and then a term of sequence. Graphically we have seen how to plot this sequence, right? And these things, these examples we have seen. This is good example. We show this, where goes, where does it goes, where does it goes. Okay, this example. Okay, so we have seen some basic examples. Now we discuss about the convergence. Okay, now we discuss about the convergence. Okay, so firstly we want to see this definition of convergence. What does it mean? So let us consider. I just take another pen. Let I just zoom it first. Let xn be a sequence. Let xn be a sequence. You know what is sequence? I have earlier mentioned. Xn be a sequence. What we say? We say xn, where xn converges. Xn converges. What does it mean by converges? Xn goes to, this is the sign of converges to x belong to, because we are talking about real sequences. Okay, if what happens, if for a given, let's first write the definition and then 0, there exist, this is the symbol of there exist, n belong to natural numbers such that for all k which are bigger than n, what happens, I just have taken n, small n, and we have what happens, we have xk belong to x minus epsilons comma x plus epsilons, right? Or what I say, this mod of xk minus x is less than, I just write it, minus x is less than epsilon, then I just first write, then x is called limit, x is called as limit, what I say is limit of sequence. Okay, that's it, fine. So then we write limit of sequence. Okay, I just then we write xn goes to x. Okay, fine. So that's it, and I just, okay. So the convergence definition is that one, and wait. So we try to understand this definition of convergence. Let's discuss this. Okay, let's see. So we have seen xn is a sequence. xn goes to x. What happens? xn converges to x. Let's understand in Hindi and English also. So xn converges to x means x is any real number. अगर xn x पे converge हो रहा है, इसका मतलब क्या है कि xn means the term after certain n are going in this neighborhood. That means if you take this neighborhood x minus epsilon, x plus epsilon, if you take this thing, then xn is going in this for all k after k term, right? It is going in this neighborhood. Okay, so this is very important to know. It means that for given epsilon, you find a natural number such that for all k greater than equal to n, xk is going in this neighborhood, or this is, or we can say xk minus x mod is less than epsilon, because this is equivalent to saying this, and then x is called the limit of the sequence. That's it. Okay, so this is the definition of convergence, and we see it graphically. Let's discuss this graphically. If you have a sequence like xn is equal to 1 by n, then I just discussed this. So what is the graph of 1 by n? Okay, 1, it is 1, 2, it is 1 by 2, 3, it is 1 by 3. Okay, it's going like this, and okay, it's going like this. So what happens is, I just say, if I make it big one, suppose this is 1, 1, 2, and this, so it is going like this. Okay, so if I take 0 as x, if I take it 0, then if I take this thing 0 minus epsilons, okay, 0 minus epsilon comma 0 plus epsilon, what does is this? It is minus epsilon comma epsilons. Okay, so make this, this is this I just make roughly it is epsilon, and this is minus epsilon. Okay, so you see this, that after this point all the terms are coming in this neighborhood, this thing, these points are coming in there, these points are coming in there, right? You can see this, these points are coming in this neighborhood. So what happens is that 1 by n belongs to minus epsilon comma epsilon for all n greater than equal to some k. right? So that's it. It means that 1 by n converges to 0, right? So this is the basic definition of convergence. So that means that if you have xn is a sequence, if you take any x belong to R, then you say that xn converges to x if for every epsilon you are able to find, you can take every, like if you take this, then you can find some points after that, right? So if you take any epsilons, then what happens, that sequence of term are getting close to x. It close to x means difference of sequence of terms of sequence is less than epsilon, right, from x. So that's the idea of the convergence. Okay, means xk approaches, xn approaches to x means xn minus x to difference is less than epsilon for all n after some terms, right? In n note after k terms it is coming in this neighborhood. That's the definition of convergence. So like this, can you find the convergence of this? Is it converge? Or can you check the convergence of n? So please comment that if you know these convergence 2 to the power n, please check does they converge. You can use the approach for the time being graphical. You can approach what I have done here, this thing here. So you can do that. So this is the idea. And 1 by n square, where does it goes? Please, you can see that it goes to 0. You can check it graphically. So this is the idea of convergence of sequence. So in the next video I will be telling about more regarding the convergence of the sequences. So be updated. So what we have seen, the definition of sequence and the some examples, the convergence, what is approximation. So I think it is, this example is make it clear right now by the definition of convergence. If you feel it interesting, then please comment, and for further improvements please comment on the comment section box. Okay, thank you very much, and we will continue our discussion in our next video regarding the convergence of sequences examples. Okay, thank you. Bye.